So now we can check and see if you've done it right by doing first 3x squared. Outside, what's that make? Negative 3x. Inside, negative 2x. That makes a total of negative 5x. And then the lasts, this times that. Positive 2. It worked. Okay. On the next one. Let's see. Who haven't I bothered for a while? Jake, tell me what to do. Two x and good. And then? How come you know it's a plus and a minus? All right. Now, do you know for sure that the plus is in the first one and the minus is in the second one? No, not at first. So these two could be reversed. Don't know yet. Okay. But we know one's a plus, one's a minus because it comes out to a negative 5. All right. So then what did you use? 5 and 1 or did you go with 2 and 3? All right. So if we use 5 and 1, now it's just a big guessing game of trying to figure out where should I put the 5 and where should I put the 1. Now, I was giving you some advice on that generally if this middle term here is big, is that fairly big? It's fairly big. It's not huge, but it's fairly big. So I would be thinking in terms of maybe putting the bigger number on the outside so that it can multiply with this 2. And then, do I want my middle term to be positive or negative? Positive, and therefore, why don't we make this a positive 5? That way it'll make it the bigger one positive, okay? All right. Is that what you got? All right, how can I tell if I'm right? I can be absolutely positive. Let's FOIL it out, yeah. So first, 2x squared. Outside, 10x. Inside, minus 1x makes 9x. Good. And negative 1 times 5 makes negative 5. It worked. First, outside, inside, last gives you the final answer, which is what you started with right here. All right, this one is for the more advanced person because it's got one extra step. Why? Yes, Kobe. Record this. So one person suggested we take out a 2, for instance, out of everything, a GCF, and somebody else said, but do you have to? No, you don't have to. You can do this another way, but taking out the 2 is the fastest way. It's kind of like reducing a fraction. If you can take out a big number right away, you can reduce your fraction all the way down to like 1/2, really quick. But if you take intermediary steps, you can factor it a little bit, and then you just have to factor it a little bit more. So if we do it this other way, where we don't take the 2 out of everything, then we could say it's like 4x and x, and then what multiplies to 10 that can go here, or negative 10. And the problem is when you're all done with it, your answer won't be factored all the way. You might have something like this in it. Did you have an answer for it?
Yeah.
What do you think your answer is? Go ahead.
I said 2x minus 1.
All right, so you can go 2x and 2x. That works. Hold on. 2x and 2x. And then you said 2x minus 1. And what? Plus 10. And now, the way you could prove, and I know you're saying, I think it works. And I think you're right that it works, but it's not factored all the way. Because why? Can anybody see it? Sarah?
Well, it could be x plus 5. So 2x plus 5.
Yes, this part right here is not factored all the way. Do you see how something could come out of that? And so your answer is right in that if I do first, outside, inside, last, first is 4x squared, outside is, let's see, 20x, inside is negative 2x makes 18x, last make negative 10. It works, but that isn't factored all the way. So I got to, this part was, this part would have to be factored into 2 and then x plus 5. And then what do you notice? We've got the 2 factored out into the front again, just like we could have done in the first place. So what's the moral of the story? If you can find a GCF, factor it out first because it'll save you a step. All right? So in this one, we should have factored out a 2 right off the bat because there was a 2 in all of them. All right, let's move on. This one. Is it a difference of squares right off the bat? No, but it will be. Solve it. Okay. Did you factor out a 3? And what were you left with? 4x squared minus 1. And I bet you some people stopped there, but they were wrong. Who went farther? Tell me how.
How much that is I put it into
2x and 2x.
plus 1.
A plus 1 and a minus 1. Is that one of those difference of squares things? Yes, it is. Because why? Because that's a perfect square, and so is 1. A lot of people forget about 1. 1 has a square root of 1, so it works nice for those. All right. Final answer's right there. Then, can you do this in your head? What are the roots? If you know it, just say it. A half and negative a half. Good. And if you had trouble with that, if you're not good at doing those in your head, then you just got to know how to set this up. 2x plus 1 equals 0 and 2x minus 1 equals 0. Then you subtract 1 from both sides. You'd have 2x equals negative 1, x equals negative a half. And over here, you add 1 to both sides. 2x equals 1, and then x equals a half. All right. So that's why we're doing them, too, so we could find the roots. That's called the zero product property, is the thing at the end that we were doing that was telling us that negative a half here and positive a half here would be my roots, because it's making this equal to 0. And why do we set y equal to 0? Because we want the x intercepts. All right. Okay, one last little note on Friday's quiz that you have. There are no calculators. I doubt any of you even used a calculator while we were just doing this, so you're not going to miss them. It'll be fine, but no calcs for Friday's quiz. And today's homework is right here. The 7.2b all, that's a worksheet you're going to have a lot of fun with this one. And then 7.2 backside.